All right, hi everybody. So I did want to just do another quick walkthrough example for looking at the graph of a polynomial and kind of getting all the information we can from it, and how we put all that together. So here's a graph of a thing, y equals f of x. Like we talked about this in class a little bit, but we're going to just kind of assume that things are what they appear to be, and things kind of work like they look like they do. So what I mean by that is, like, what we see here kind of shows us what we need to know. There's not some like crazy thing that happens off of the graph somewhere that I can't see it. So this end continues downward like it looks like it does. This one continues up. There's no other stuff that happens later on. So things that we need to be able to identify would be the zeros, their multiplicity, the degree, the leading coefficient, and then kind of put all that together to write down an equation for this thing in factored form. And I'll talk more about the factored thing in a second, but let's start with the zeros. Zero, again, means the same thing as x-intercept or real root. Those words are all kind of used interchangeably. I'm mostly sticking with zero, but it means the same thing as x-intercept. So I've got 1, 2, 3 places where this hits the x-axis. I'm just going to write the values of those down: -4, -2, and 3. Now, multiplicity refers to the number of times that root or that zero counts. And what that does is tell us about how the graph looks kind of locally near that crossing. So like here, if I kind of just only pay attention to this part of the graph, like right by that intercept, what it looks like is basically like a straight line. Like there's a little bit of curvature to it still, but it pretty much just goes straight through the axis there. Compared to here, where what happens nearby is that we've got a thing that looks a little bit like a parabola, like it bounces off the axis. The graph is turning around, changing direction at the same time as it hits the x-axis. And then the same kind of thing here, right? Just kind of within that circle, it looks a little bit like a parabola. That tells us about the multiplicity, because that first one at -4 just kind of goes straight through. It's got multiplicity 1. The other two have multiplicity 2, which means that those zeros sort of count twice. It means that the factors that they go with show up twice. And it means that the degree of this thing we can find by adding those up. So 1 + 2 + 2 would be 5. 1 + 2 + 2 is 5. A thing that has degree 5, well, since it's odd, the ends would go in opposite directions, like these do, one up, one down. It's got 1, 2, 3, 4 places where the graph turns or changes direction, and there are 3 zeros, but they sort of count as 5 because of the total multiplicity thing. All of that tells me that the degree has got to be no smaller than 5, and everything that we're going to do, we're always going to assume that it's kind of as small as it could possibly be. So the degree here has to be odd because the ends go in opposite directions. It can't be 1, it can't be 3 because there's too much other stuff going on. 5 is the smallest it could be. For the leading coefficient, I'm just going to look at how it ends up, like what the graph does eventually. The leading term is so much bigger than all the others eventually that whatever this does tells me the sign of the leading coefficient. It points up, so leading coefficient's got to be positive. Okay, then putting all that together to write down the factored form of the function, basic idea is that we've got the leading coefficient, and I'll write this in a different color. Like, you don't have to write that plus out in front of everything. I'm just kind of doing it for emphasis. But then the factors come from the zeros. So if you think about solving an equation, if you factor it, each factor tells you about some zeros. That relationship also works the other direction. It's an if and only if statement. So if you know zeros, then you know about factors. So there's a 0 at -4 that has multiplicity 1. that means there's a factor that looks like x plus 4 that appears one time, right? So again, I'm going to write that in orange because we don't really need it, right? A first power, but that's where the multiplicity shows up. -2 being a 0 means there's a factor that looks like x plus 2. Its multiplicity being 2 means that that factor shows up twice, so it's squared. 3 being a 0 means there's a factor that looks like x minus 3. Highlighting things. Its multiplicity is 2, so squared. And then you could check, right? So if you punch this into your calculator or Desmos, you could take a look at the graph. Now, notice here that like the scale on this graph is a little bit weird, right? Because it's very tall. So it might look a little bit different unless you mess around with the window settings or the zoom. But you can at least, kind of use that as a way to check to see if the thing makes sense. Okay, so there's that. There's a example of how we do that. If y'all have any questions, let me know.